A very good morning to one all present here. This is Jayaprabha. I'm going to present a research paper on CKD, chronic kidney disease identification, using the deep learning method. So CKD leads to the gradual loss of kidney function. So it affects the millions of the people worldwide. In early stages 1 to 3, the patient should not show any kind of visible symptoms. So the diagnosis is usually delayed because of the late symptoms. So too many advanced treatments are arised, even though the dialysis, kidney transplant are very costly for the common people. The only way to protect the CKD is early identification. So as per the KDIGO 2024 definition, KDIGO is kidney disease improving global outcome. So they defined one definition for the CKD, which means the abnormalities of the kidney structure or the function. It's called as CKD. So these abnormalities present for at least 3 months, which cannot be easily predicted. So it will affect the blood pressure, waste removal of the kidney, anemia, bone health and heart risk. So there are two kind of diagnosis are available. One is reduced glomerular filtration rate, other one is the markers of kidney damage. So due to this two kind of reason, the person may get a kidney disease, and in this chart the protein in urine and the GFR in the blood both will be the major cause for the CKD, and this is what the stages we found in kidney disease. And G1, G2, G3, these 3-4 stages will not be visible for the people, and G4 and G5 stages or G4 and G5 stages is the most dangerous stages, and most of the mortality happens in this stage. An objective, the major objective of the CKD research paper is to create an automated deep learning method framework, and the classifiers such as convolution, attention and bi-LSTM for the early prediction of the CKD. So it minimizes the need for the manual feature engineering and enhancing diagnostic accuracy. To design the probabilistic feature-based variation autoencoder, that is PFVAE, integrated with the structural RNN and convolution LSTM models to capture the uncertainty spatial temporal dependencies and the latent representation in clinical dataset for the robust CKD prediction. So this kind of PFVAE algorithm and the structural RNN and the convolution models easily predicts the kidney disease with the highest precision level. And the next one, to perform a comparative analysis of the proposed AutoDL and the PFVAE based spatiotemporal deep learning models against existing benchmark machine learning and deep learning methods, evaluation performance across the metrics such as accuracy, precision, recall, F1 score and AUC. This is the major flow diagram of the work. The data collection, which means the 24 attributes of the kidney disease which is mentioned by the KDIGO, will be extracted from the data set, and the data pre-processing, AutoDL, SDRB and PFVAE is used to find the CKD, and finally with the help of the SHAP we can easily identify the CKD progression and we'll get the prediction of the output. And this is the architecture diagram. So AutoDL classifier, SDRB RNN and PFVAE plus STDL is finally we are getting the performance evaluation, and each phase is having a very important representation in this. So in literature review, I used I had the 3 base papers. So in all the 3 base papers, we had the common random forestry, support vector machine, and the decision tree has been used. And the decision tree has been used in most of the papers. And the major drawback here I found is it's a static model research, which means it will detect the CKD based on the current records and it won't check the previous or the future records, and that is a major limitation of the works. And the first methodology, in this first methodology The automated deep learning is used to simplify the neural network design. So it will be focusing on the early reduction of the CKD using the routine clinical features, which means identifying the blood samples and collecting the urine samples and the blood pressure, heart rate, everything will be extracted from the patient's health record instead of the manual architecture selection. So in all the time the human intervention will be more to calculate the architecture selections, but now in this AutoDL method we are using the automated discovery method. So the data is pre-processed using the missing values handling and outlier removal and normalization of the reliable prediction. So in this phase, in this methodology, the data acquisition utilizes the UCI CKD data set, and it collects the patient's record and it identifies the CKD. Data pre-processing and imputation is calculated with the help of the K nearest neighbor algorithm, and it is used to fill the missing values based on the patient's validity. The scaling of the minimum and maximum normalization to standardize the clinical units for the Foster model convergence. So the architectural search implements the neural architecture search, that is NAS controller. It iterates through the search space of various LSTM configuration. So the model composition, it uses the by LSTM, and optimization uses the ADAM optimizer and the cross entropy loss function to refine the weight parameters, and it uses the KNN imputation also for the pipelining the cleaning process. So everything is finally frameworked as the AutoDL controller. It used to search the best combination of the convolution LSTM and the by LSTM layers, and it ensures the model in mathematically and optimizes the CKD prediction. So this is the workflow diagram: pre-processing, AutoDL, and NAS, and classification. And the architecture diagram: the input layer, pre-processing block, AutoDL, convolution, attention, and by LSTM. And finally, using the softmax layer, we are predicting the probability of the CKD. So we used KNN imputer, AutoDLNAS, LSTM variance, which means convolution LSTM and by LSTM, and finally softmax probability prediction. And this is a pseudocode for the algorithm: pre-processing stage, automated model search, training stage, validation and evaluation, deployment, and finally the result. So we got 94.2 percentage of accuracy level, and the AutoDL selected the optimal convolution LSTM by LSTM architecture from the search space. And clinical features such as creatinine, BP, hemoglobin, and the albumin had the highest influence on the prediction from the SHAP. And this is the accuracy. So proposed AutoDL has the highest level of accuracy comparing to the previous existing methods, and the precision, recalling, and score. And finally the summary. Here the LSTM framework achieved a strong performance of 94.2 percentage comparing to the existing algorithms. And in second methodology, the missing values are filled efficiently with the help of KNN imputation, and all features are standardized using the min-max scaling from the UCI CKD dataset. The stochastic deep radial basis function converts the noisy clinical data into the stable and meaningful features. So when we analyze the clinical data of a patient, we may get too many noisy and redundant data. Everything will be cleared with the help of the stochastic deep radial basis. And the resonant blocks will used to um, go deeper into the layers, and the clinical informations will be analyzed very thoroughly. And the bidirectional LSTM is used here to learn the patient's data patterns. So in 3 months, how many variations they have, how the data has been changed, everything can be analyzed with the bi-LSTM. So the used algorithm in the methodology 2 are SDRB, the ResNet, and bi-LSTM. And the pseudocodes, we used automated SDRB for the feature extraction, the RNN for the classification stage, and bi-LSTM for the temporal modeling. And in this design, The SDRB layers handles the stochastic clinical noises, and ResNet skips the connection maintenance data integrity and higher dimensional refined feature mapping and accuracy, and it has the highest precision in the recall level, and the FR measure also higher than the previous models. And the summary, the hybrid model combining the SDRB, ResNet and BioSTM for medical diagnostics, and it addresses the clinical data noises and model instability. So outperforms existing model with improved accuracy and the stability of the data identification, and the positive prediction value and the negative prediction value will be balanced equally. And methodology 3, this is the major methodology of the work, PFVAE integration. So the probabilistic feature variational encoder, autoencoder to handle the missing data and model uh, the underlying the distribution of the patient record. So the structural RNN implemented version of the recurrent neural network, it identifies the complex hierarchy of the medical features. The spatio-temporal fusion combines the spatial features extracted via the VAE with the temporal sequence. It captures via specialized RNN units. The confidence estimation, the framework output not just a result, but a probability score, it indicating the likelihood of the CKD. So this is the flow diagram of the work, and this is the architecture diagram. Here we used PFVAE algorithm, spatio-temporal framework, and the explainable AI, that is SHAP for the integration, and this is the pseudocode PFVAE encoding, decoding, integration, classification and training, validation. And the uncertainty aware, the latent space modeling, the spatio-temporal modeling are the major attribute of this work. And methodology 3, we got the highest accuracy level, and the precision also very good. And in overall methodology, accuracy got by the AutoDL method. So after finding the patterns, spatio and temporal, the accuracy level is maintained clearly. The result analysis of the all three work, the strong regularization, which means dropout, early prediction, the residuals, everything is regularized properly, and tenfold CV with mean positive and negative standard reporting, and smooth for the class imbalance. And the feature selection, probabilistic modeling in work 3 for uncertainty handling, and stabilizing the performance, it gets 94 to 96% of the accuracy level. So combining PFVAE, structural RNN, convolution LSTM, it creates the efficient pipeline of the CKD prediction. And comparing to the previous LSTM, GRU, CNN, RNN and the transformer architecture, this AutoDL classifiers will provide a highest level of accuracy, precision, recall and score. And the conclusion, this method provides the very good prediction level for the CKD, and the multi-stage hybrid architecture is the novel of my work. And it strengthens the classification, improves the reliability, enables the real-time clinical monitoring, and supports the early stage detection and demonstrate the AI methodology. The future enhancement of my work is to apply the AI concept very deeply and to make this as a wearable devices, and also to give these algorithms to identify the chronic illness like diabetic, cardiovascular diseases and degenerative disorders. And these are all the reference I took for this my research work and my publications and the book I published and the patent rights we got and the research colloquium completed and FTP courses I have attended. Thank you.